Okay, welcome back to learning about different types of chemical reactions. In this video, I will only be covering single replacement reactions. They're also known as single displacement reactions. Okay, so the double displacement reactions or double replacement reactions will go on a separate video. This video right now will cover several examples so that you have a couple of things to go back to and study, and so that you go back to and observe several problems to being resolved for practice and repetition purposes. Now, you do not have to watch this video. You do not have to watch the entire length of it. There are 5 different examples that I'll go through here so that you get an idea of what things to look for when you're trying to predict the product of single replacement reactions. Okay? So, things that you need to know. Number one is you need to have your table of reactivity or your activity series table. You will also need the table of polyatomic ions, okay? And of course, that periodic table so that you know the charges. Here we go. So for you to be able to determine whether a reaction takes place in a single replacement reaction, you have to look at the activity series to see if the lonely element can replace one of these ones. And the rule of thumb is a metal replaces a metal, a non-metal replaces a non-metal. So basically, likes replace likes. And you can also think of it this way. If lithium has a positive charge on the periodic table and sodium has a positive charge on the periodic table, they can replace each other because they have the same charge. Lithium cannot replace chlorine because lithium is a metal, chlorine is a non-metal. So we cannot replace that one. Okay? So in this case, let's look at the activity series to determine whether or not lithium appears on that list above sodium. Okay, let me find that real quick. We're looking at lithium and sodium. There is the activity series for the metals. Lithium is at the very top. It can replace anything below it. Okay, let me show you. Lithium appears right here, and it will be able to replace anything below it. So the question is now, is lithium above sodium? Yeah, lithium is above sodium, so it can replace it. The reaction does take place. If it wasn't the case, then you would just write down no reaction. So lithium will replace sodium. Let's go back. And to be able to write down the new product, let me go ahead and get my pencil. We're going to rewrite it so that sodium is no longer there. Lithium will now be paired with a chlorine. Okay? Let me bring over my table of, there it is. So in this case, the new element that will be lonely, it will be Na. It's single now because that one was replaced by the other single. My new compound will be lithium and then the chlorine. Now, at this point, we have to think about whether or not my charges are canceled out. Are they balanced? Let's check. Lithium, according to your periodic table, has a 1 plus charge, and chlorine has a 1 minus charge. So that one is good. We do not need a crisscross method for that one, unless if only if the numbers were different, then you would do it. The sodium is a lonely element. Now, if you think about it, it's a metal. It doesn't need a 2 because it's not part of the diatomic molecules. If you check your list at this point, check your list for sodium and determine whether or not it's there. And you'll find that it is not there. So there is no little 2. That little 2 should not be there. Okay, so I'll get rid of it. Okay, that's pretty much it for a single displacement or single replacement reaction. One replaces the other if the activity series indicates that the reaction can take place. So all it is right now is to determine whether or not the chemical equation is balanced. We have one lithium on the other side of the reaction. On the reactant side, we have one sodium. On the product side, we have one sodium. We have one chlorine. So this was a nice little chemical equation. We predicted the product and it actually came out balanced. So that's nice. We don't have to worry about balancing it anymore. It is balanced. We're going to move on to the next example, in which I have sodium bromide, NaBr. Let me scroll down a little. Now, In this case, notice that I do have sodium and it's a metal. Bromine is a non-metal. Fluorine, if you look at the periodic table, is a non-metal as well. If you look at them too, fluorine has a negative charge. Bromine has a negative charge. So what will replace what? In fact, if you want to, you can go ahead and write the charges now. If you look at the periodic table, sodium has a 1 plus, bromine has a 1 minus, fluorine individually has a 1 minus as well. So the negatives can replace each other. The negatives cannot replace the positives. So let's go ahead and perform the replacement. Let me go ahead and clean it up a little. In this case, fluorine will replace the bromine. And instead of NaBr, we're going to have NaF because that's what we're replacing it with. So let's go ahead and write it down. We have NaF. And again, notice I did not bring the little 2. Why? You can go back to the previous videos to find out, or I'll remind you. You can never bring any of the little numbers, any of the subscripts, because you will only use the crisscross method to determine what little numbers go there. The only time that you will is if you see a polyatomic ion, which is the next example, and I'll show you that. Okay, let me clean it up a little. Okay, who is my new lonely person in this case, or my new lonely element? In this case, it's going to be Br. If you look at the list of those diatomic molecules, bromine is there, so you need to put a 2. Okay, let's check the charges. Sodium has a 1 plus, fluorine has a 1 minus, based on the periodic table. Do we need a crisscross? Not in this case, because the numbers are the same. Okay, so it looks good. Let's just double check and see if it's balanced out. Is the equation balanced? Let's see. 1 sodium looks good. 1 bromine, 2 bromines. We're going to have to go back and put a 2. Let me clean it up a little. 2 bromines, because I put the 2, but I made 2 sodiums at the same time. Therefore, I need to put a 2 right there, so that I have 2 sodiums. At the same time, I made 2 fluorines. If you look right there, I have 2 fluorines. The equation is balanced. If you're not sure about it, double check it, and you will notice that it is balanced. We have the same number of sodiums, bromines, fluorines on the reactant side to those of sodiums, fluorines, and bromines on the product side. So left and right, same numbers of atoms. Another problem. There it is. Another sodium. Boy, I like sodium. Sodium reacts with iron sulfate. Now, that iron sulfate looks quite interesting. Anytime you're performing a single displacement reaction, you need to double check to see if there is a polyatomic ion in there. The way you check is, well, first of all, in the first couple of problems, notice how I had compounds that had pairs. So there were two different types of elements, or singles, but then again, it was pairs and singles. In this case, I have a single, which will be doing the replacing. And in this case, I don't have a pair of elements. I actually have 3 different types of elements. That's the key indicator that you have a polyatomic ion, which means you need to go to your table of polyatomic ions to determine which one is it, so that you know the charge of it. Okay? Let's see, where is my table of polyatomic ions? Right here. Okay, we're looking for sulfate, SO4. I'll highlight it with yellow so that you can see it. Sulfate is right there. It is SO4 and it has a 2 minus. So let's go ahead and go back to the problem, and let's go ahead and include the fact that it has a 2 minus. All right. Sulfate, I'm going to put a parenthesis so that I remember that that's the polyatomic ion. There is nothing wrong with putting a parenthesis. And this one, according to the table of polyatomic ions, is a 2 minus. If there is no little numbers right there, since one is a -2, the other one must be a +2. So they can cancel out. And therefore, you didn't need to do the crisscross method. Okay. Now let's go ahead and perform our single replacement reaction. In this case, we had to go back and double check whether there was a polyatomic ion or not. All right, so the sodium, just like we did before, will replace the iron. Will it? Well, let's find out. Let's double check the activity series. Can that reaction take place? Let's go to the activity series. Can sodium replace iron? Let's see. Sodium is right here. And iron is right there. Yeah, it's above it. Sodium is above iron. Therefore, we can replace it. The reaction does take place. So let's make sure it does. My lonely element will now be iron because it got replaced by sodium, which is now combined with a sulfate. Here is where this is the only time in which you will include the little 4. If it's in a polyatomic ion, you have to bring the little 4. So SO4. You will never bring any subscript, only if there is a polyatomic ion. And for that reason, I include the parentheses because it becomes a little easier for you to visualize where they are. Okay. Now let's double check our charges. Let's double check everything to make sure that all the charges are satisfied and balanced out. Sodium, according to your periodic table, says that it has a 1+ charge. According to the table of polyatomic ions, sulfate has a 2-. Okay, do I need to do a crisscross method? Yes, I do. I'll need to put the 2 right here. In fact, let me use a different color since it's quite narrow in there. I'll put the 2 right there. Okay. And I think I erased the parentheses. Let's go ahead and fix that. Okay. And the 1+ right there, you could bring it down here. I understand what you mean by that, but technically, again, in chemistry, it is a convention that we don't include the 1. Okay. If you want to leave the parentheses, you can. You don't have to though. Okay. So in this case, I can get rid of it if I wanted to, but there's no need for that right now. Let me erase a little bit of that. That's it. For that type of chemical reaction in a single replacement reaction, we replace the iron, the Fe, with the Na because according to the activity series, sodium can replace iron. We brought everything inside the parentheses of a polyatomic ion. That's why we have the little 2. Nowhere else will we have the little 2 or the little 4 anywhere else. Okay, that red 2 is there because of the crisscross method. So let's now balance the chemical equation. Let's double check. We have 2 sodiums on the right side. So I'll put a 2 right there. 2 sodiums on the left. Now I have 1 iron on the left, 1 iron on the right. How many sulfurs do I have? 1 on that side. I have 1 inside the parentheses. I have 4 oxygens. I have 4 oxygens. So it's balanced just by placing that 2 on the left of Na. Now you could also think about it this way. I have 1 parenthesis of sulfate or one parenthesis of SO4. I have 1 parenthesis of SO4. You can also think of it that way. Or if you want to say I have 1 sulfate ion, polyatomic ion, you can on both sides. But anyway, the case is you have the same number of atoms on both sides. I'll delete the parentheses because that looks better. Later, you'll have to keep it if you had a number that would go right next to it. Let's say, for example, if you had a 3+ on that one and you had to put the 3 right there, if you don't keep the parentheses, it'll make it look like you have 43 oxygens rather than you actually, well, you don't. You only have 4, and that 3, they multiply together. But that's on a different case.